Hello students, today in this video we are going to discuss regarding calculation of SAG in category 1 numericals. So while calculating the numericals for SAG, there are two categories. The first category named as when sports are at equal level and the other category named as when sports are at unequal levels. As both the categories have been discussed theoretically, so today in this lecture we are going to discuss numerical on the category 1. The category 1 is when sports are at equal levels. So before starting the numerical, let us discuss uh, the category 1. The formula for calculation of SAG is WTL square divided by AT. So this is the basic formula for calculation of SAG. Okay, but this formula stands valid only for conductor in still air. कंडक्टर के ऊपर सिर्फ उसी का ही वेट है. कंडक्टर इज एक्टेड अपॉन इट्स वेट ओनली. मतलब दो टॉवर्स हैं, टॉवर्स के बीच ट्रांसमिशन लाइन सस्पेंडेड है. जो ट्रांसमिशन लाइन का वेट है दैट इज वेट ऑफ द कंडक्टर ओनली. In case of transmission line, there are other two effects also. The other two effects are the effect of wind pressure and the effect of ice loading. So we have to calculate the effect of wind pressure and ice loading also. So in the numerical, sometimes it is given the wind pressure and sometimes it is given the ice loading. So we have to calculate the total weight that is represented by WT. L is the length of the span, T is the tension in the conductor. So while look at this phasor diagram, the this line represents the total weight of the conductor. This is the weight of the conductor due to wind pressure, and the ice loading effect is acting vertically downwards and weight of the conductor is acting vertically downwards. That's why both the weights have been added in the downwards direction and effect of wind is acting horizontally. So when we look at this diagram, suppose this is the conductor. Okay, wind pressure is acting horizontally, whereas the effect of ice loading, these coating represents ice loading. So the effect of ice loading and the weight of the conductor acts downwards in the downwards position. Wind pressure acting horizontally and the ice coating is acting in the vertical direction or in the downward direction. So total weight of the conductor is wind pressure weight plus weight of the conductor itself plus ice loading weight, that is represented by WT. So this formula is used for calculating slant sag. Okay? If in the numerical it is given that you have to calculate vertical sag, then the value of S calculated from here had to be substituted there. So let us discuss our numerical number 1. A transmission line has a span of 150 meter between level sports. एक ट्रांसमिशन लाइन है, उसका स्पैन है 150 मीटर का between level sports. The conductor has a cross sectional area of 2 centimeter square. The tension in the conductor is 2000 kilogram. If the specific gravity of the conductor material is 9.9 gram per centimeter cube and wind pressure is 1.5 kg per meter length, you have to calculate the sag. The next part is what is the vertical sag. In the first part, you have to calculate the sag, and in the second part, you have to calculate the vertical sag. So in the numerical, is saying that you have to calculate two things. The first thing is sag, that is slant sag, and the other thing is the vertical sag. Okay, so let us start with the numerical. Before solving the numerical, let us see what is given. Span length is given 150 meter, 150 meter. Tension is given 2000 kilogram, that is 2000 kilogram. Wind force is also given. Wind force pressure is 1.5 kilogram. Now what is not given? The ice coating effect is not given. We have to neglect it. Now what we are left we are left with this, the weight of the conductor. We have to know the weight of the conductor in order to calculate W2, because W2 is substituted in the formula. Okay. Wind pressure is given. You have to calculate weight of conductor by adding both these, by applying Pythagoras theorem. Hypotenuse का square equals to base का square plus perpendicular का square. So tension is given in the numerical, length of span is given, though W is not given, weight of the conductor is not given, total weight of the conductor. So we are calculating the total weight of the conductor is, weight of the conductor per unit length is, specific gravity is given as 9.9 gram per centimeter cube, multiplied by volume of 1 meter conductor. Okay. But the cross sectional area of conductor is given in 2 centimeters square. So centimeter must be converted into meters. That is why this is multiplied by 100. Okay. So the answer will be 1980 gram. The final answer will be 1.98 kilogram. So we can now, the wind pressure is calculated. It is already given. The weight of the conductor is calculated. Effect of ice loading effect is not given. We can take it as a zero. So total weight of the conductor for 1 meter length of conductor will be calculated as, total weight of the conductor can be calculated as weight of the conductor and weight of the wind pressure. So answer will be 2.48 kilogram. We had applied simply here Pythagoras theorem. Hypotenuse का square equals to base का square plus perpendicular का square. As before discussing this numerical, the value of sag is calculated as, in this value we will put the value of sag is 3.48 meter. But this is the slant sag. In the question, it is given that you have to calculate the sag. This is the slant sag we have calculated just now. In the next step, we have to calculate the vertical sag also. So while calculating the vertical sag, the formula for vertical sag is S cos theta. We know the value of slant sag. What we do not know is the value of theta. We have to calculate the value of theta. The value of theta can be calculated from here. Theta, we can write it as tan theta equals to perpendicular upon base. So from this we get tan theta equals to 0.76. While taking tan right hand side, taking the tan inverse of 0.76, we get this much degree. Substitute this value of theta in this formula. As we know slant sag, theta we know, just calculate it, we get our answer as 2.77 meters. Thank you.